Hello everyone. In this video, we'll take a look at how to find the factorial. Okay. Now, how is factorial defined mathematically? It is defined as n factorial equal to 1 into 2 into 3 into so on up to n. Okay. Now, can we also say that this is n factorial equal to, here there is, see, here I can also say that this is like n minus 1, okay, n minus 1 into n, right? So therefore, I can say that if I combine all these terms together, I can say that this is nothing but n minus 1 factorial multiplied by n, right? So I am successfully able to achieve recursion over here. That means I'm able to define factorial. I'm able to define factorial in terms of factorial. Okay. I'm able to define factorial of n in terms of factorial of n minus 1. Now, if I start with this recursion, let's say I want to find factorial of 5. Okay. So how will this work? 5 factorial is 4 factorial times 5. Then 4 factorial is 3 factorial times 4. Then 3 factorial is 2 factorial times 3. Then 2 factorial is 1 factorial times 2. Now, we can either define 0 as the base case. The advantage is if the user enters 0, then it's better than that way. Otherwise, we could have defined 1 as the base case as well, but the user may say, I want 0 factorial, right? So we can have 0 as the base case. So 1 factorial is 0 factorial times 1. And we don't go negative. We don't go beyond this. We stop over here. So our base case in this case is, this is how the base case looks like. Base case is 0 factorial equal to 1. This is the base case, right? Let's code this now. Okay. So int factorial again. Now I can define it as int factorial. Fine. So 5 factorial is 120. 6 factorial is 720. Now factorial increases very fast. So by the time you reach 15 factorial and 20 factorial, it is possible that it crosses the range of int. So therefore, it is better to define the return type as long, because factorial function will return the value of the factorial, and that value may be very large. It may not fit within the range of integer, which is 2147483648. You can roughly think of it 9 digits, or roughly 9 digits, slightly more than that. Okay. So basically, long is a safer option over here. Now, what was our recursive step? Recursive step was, again, if you write mathematically, it is n factorial equal to n minus 1 factorial into n. Now, n factorial itself is the function call only. Now, we are saying factorial of n, the way left hand side. So, for the right hand side, what we want to do is, what we are saying is factorial of n calls factorial of n minus 1. So, factorial of n calls factorial of n minus 1 multiplied by n. Okay, and then you multiply by n. Okay, then factorial of n calculates this value and returns it. Okay, now first we have to check for base case. Always in the recursive function, first you have to check for the base case, and then you have to write the recursive case. Because if the base case is not there, your function, your recursion will not terminate. You will get segmentation fault, because as we had discussed in the lecture, basically whenever you call a function, a stack is involved, and when you create an infinite recursive function, basically the stack smashing, basically the stack gets completely filled. Stack overflow, you can say, stack smashing. Basically the stack runs out of memory and it causes segmentation fault. Okay, so first we will check the base case always, so that this problem does not occur. Okay, so that's it, and we can run it for 5. let's say 6 factorial, factorial 6. Okay, factorial 6 is 720. The output is not as pretty, but yeah, okay. I hope the concept of recursion in factorial was clear. If it wasn't, if you have any small doubt, even if it is a small doubt, whatever doubt you have, do ask in the comments below. Thanks for watching.